Hello, this is Mr. Henry, and welcome to lesson 13.2. Today we're talking about finding the probability using permutations. The essential question says, how do I find the probability using permutations? So we've got to get the goof down here. It's talking about finding the odds. So go ahead and take a second or two. Do that problem if you have not done so yet. It asks you to find the odds of a number. What are the odds of the... Let me try this again. The odds of rolling an odd number with a number cube. Explain what the error was made. So they are saying the odds of rolling an odd number on a number cube is 2 out of 6. There we go. Got my tongue working. So go ahead and try the problem right now. Well, let's see. First thing first is they have theirs out of 6, which would be probability. But even at probability, their answer is wrong, because on a dice, there are 3 odd numbers. 1, 3, and 5. There's a total of 6. So if you were talking about probability, this would be the correct answer, and you'd simplify down to 1/2. But they're asking for the odds of it. So the odds is the thing that you want, 3 of them, compared to the stuff that you don't want. Well, if there's a total of 6, there's 3 that you want, and there's 3 that you don't want. The other 3 numbers would be the even numbers, 2, 4, and 6. So then you would simplify it down, you get 1 to 1. So that was the error, is they did probability and they did it wrong. The correct answer, there's a 1 to 1 odds of getting an odd number on a number cube. We have 2 vocab words here today. We've got a permutation, and a permutation is an arrangement of objects in which the order is important. And n factorial is, it says for any positive number n, the product of the integers from 1 to n. Now, I personally am not a fan of that definition of factorial. What it really means is if you have a number, say for example 3 factorial, you take that number times by every number less than it. So 3 times 2 times 1, that's 3 factorial. And you'd actually multiply it out. So 3 factorial would equal 6. Or if you did something like 5 factorial. Ooh, missed. 5 factorial would be 5 times 4 times 3 times 2 times 1, which, let's see, that's 20 and 60 and 120. Okay, so that's what factorial means. You take that number times by every number less than it to 1. A permutation says it's an arrangement in which the order is important, meaning you're making an ordered list, or you're picking something for first, something for second, something for third. This could be examples like coming up with a first, for example, how many ways can you get a first, second, and third place from 50 runners? Well, it matters who comes in first, who comes in second, and who comes in third. Or it could be trying to make a list of stuff at the grocery store. How many ways could you get these particular items from a grocery store? Well, you can't get them all at the same time, and they're not all in the same place, so the order would make a difference if you go to one aisle versus another aisle. So the order would make a difference in how you go grocery shopping. So that's what we're talking about with the order is important, where something's coming in an ordered list. This is first, this is second, third, fourth, fifth, sixth, seventh. Okay. Now we have a formula for this, and this is a screenshot taken from the textbook. So it has here the number of permutations of n objects, which, by the way, this is how you write permutation. This says n permute n, which means that first number here is the total number of objects. So in that example I gave, there's like 50 people in a race. Well, that means that there's 50 permute. And if you're just trying to find the first 3 people, 50 permute 3. So total number of people, the number of people that you're actually counting. In this case, just the first 3. Okay. But if it's, for example, 50 permute 50, well, that means you do 50 factorial. And there's an example with numbers. So 4 permute 4 is 4 factorial, blah, 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 24. Where it gets ugly is if you're not using just, for example, 4 permute 4. If you're using here, like 4 permute 2. So you put 4 factorial on the top over 4 minus 2 factorial on the bottom. Oopsie. There we go. So over 4 minus factorial 2 on the bottom. And then what we can do is we can actually cancel out common factors. Now we'll see how this works out here in a minute. First problem we got here asks us, says, how many ways can you arrange all of the letters in the word July? Well, so we're going to do 4 permute 4 because there are 4 letters total and we're using all 4. Now here's how I like to do permutations, and this is going to be the exact same way as this big huge ugly mess down here. I just make it a little bit simpler on myself. I think, well, I'm using 4 objects, so I put 4 blanks. In my first spot, I have a total of 4 possible letters that could go there. I could put the J, the U, the L, or the Y. So I've got 4 options. Now, if I play pretend and say I pick a letter, how many options do I have left for my next spot? Well, since I've already picked one, there'd be 3 options left. And if you pick another letter, for your next spot, there'd only be 2 options, and then finally 1 option. And you'd multiply them together, and that would give you 4 times 3 is 12, times 2 times 1 is 24 possible ways you could rearrange all of the letters in the word July. Now look what we have here, 4 permute 4, my explanation of how it's done. In that last example it showed, there's 4 permute 4, and that's how they got it. Hopefully my way makes a little bit more sense on why it's 4 times 3 times 2 times 1. It's not just, oh, here it is, do it. That's why, because you're picking a letter each time, and so there's only like 1 number less each time because you've already picked 1 possibility. Letter B. How many ways can you arrange 2 of the letters in the word July? Okay, well, there's still 4 total, but this time we're picking 2 of them. So we just want 2 blanks because we're picking 2 letters. For my first spot, I've got 4 options of letters. I could put the J, the U, the L, or the Y. Now again, imagine you pick a letter. For your next spot, you'd only have 3 left. Multiply it out, you get 12. This is how I do permutations. This is the Mr. Henry approved method of permutations. Now, if you wanted to look at that big, huge, ugly method that it showed, here's what it would be. So it would be 4 permute 2, which would be 4 factorial over 4 minus 2 factorial. 4 factorial is 4 times 3 times 2 times 1 over 4 minus 2 is 2. So this and this simplifies. So 2 factorial is 2 times 1. Now, what they're doing here is you see what common factors do you have on the top and bottom of your fraction. Well, I can divide by 2 on top and bottom. If I divide by 2 here and here, they cancel. Divide by 1 and divide by 1. Look what's left over. Just 4 times 3, which equals 12. That's the same thing I have, but my way, to me, makes more logical sense than saying, here's a formula, plug in some numbers, and it spits out an answer. This is why it's just 4 times 3. You're picking 2 out of the 4 letters. But you may use whichever way you like. Letter C asks you to find how many ways you can arrange 1 letter from the word July. I'd like you to pause the video, do this problem right now. When you are done, hit play, and we'll go through it together. Okay, so you're doing 4 permute 1. You're picking 1 letter from the word July. So you get 1 blank, and you plug in the 4. Well, There's 4 options, so the answer is 4. If you did the big nasty, 4 permute 1 gives you 4 factorial over 4 minus 1 factorial, which would be 4 times 3 times 2 times 1 over 4 minus 1 is 3. So 3 times 2 times 1, and these cancel, and these cancel, and these cancel, and you get 4. So, my way, the formula way. These 2 problems come from the textbook. This is the Now Your Turn, coming from page 851, numbers 1 and 2. So, how many ways can you arrange the letters in the word mouse? And number 2 says, how many ways can you arrange 3 of the letters in the word orange? Go ahead, pause the video right now, do this on your own. When you're ready to continue, hit play, and we'll go through it together. Alright, so number 1, there are 5 total letters, so 5, and you're picking, well, you're using all of the letters. It doesn't say just picking 2 or 3, so you're using all 5. So you got 5 blanks, so you're using all 5, and you're starting at 5. So there's 5 letters for the first spot, and you pick one, and now there's 4, and then there's 3, and then there's 2, and then there's 1, giving you a total of multiply, multiply, multiply. What did you say? 120 possible ways that could be arranged. Now, letter 2, there are 6 letters in the word orange, and you're picking 3 of them. You're arranging 3 of the letters of the word orange. So since you're only using 3 letters, 3 blanks, for your first letter, you have 6 options because you haven't picked anything yet. So you have all 6 of these options. Then you pick a letter, now there's 5 options. You pick a letter, now there's 4 options. And that also gives you an answer of 120. Now, I'm going to show this guy using the nasty formula way, and you check it out. So we've got 6 permute 3, which means you get 6 factorial over 6 minus 3 factorial, which is 6 times 5 times 4 times 3 times 2 times 1 over 6 minus 3 is 3. So 3 times 2 times 1. Cancel out, cancel, 2's cancel, 1's cancel, and look what you're left with. You're left with what I have there. 6 times 5 times 4 is 120. So you choose the method you like. So those are permutations. Now, here we're going to check out another little word problem, permutation problem. It says here, your band has written 12 songs and plans to put the songs on a CD. Okay. How many ways can they arrange 9 songs on the CD? Now, this is a permutation because of 2 things. First off, if you're talking about an arrangement, that's a permutation because the order makes a difference. What song comes first? What song comes second? Okay, so they're trying to arrange the songs on a CD. If you were just trying to pick some songs, that's a completely different problem, which will be actually the very next lesson. But if you're putting them in a specific order on the CD, this song comes first, this song comes second, that's a permutation. So what we're going to do is we got to do our 12 songs permute 9. Well, let's see. That would be 9 blanks, because there's 9 songs. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can get 12 songs for the first spot, because any of those 12 songs go into spot number 1. And I've picked one, and there's 11, and then there's 10, and 9, 8, 7, 6, 5, 4. Multiply them out. And we got ourselves an answer. Now, I just quickly paused the video. I pulled up a calculator here, because, well, it's more than I want to do in my head or on paper. And when I multiplied out, I got 79,833,600. So 79 million. Try it again. 79 million. There we go. 833,600 different ways. So think about that. For just putting 9 songs on the CD out of 12, there's almost 80 million different orders of 9 songs on that CD. Most people wouldn't think there'd be nearly that many. 80 million. Now, if you're only doing 7 songs, well, it'd be the same deal. 12 permute 7. So you're only going to put 7. So 1, 2, 3, 4, 5, 6, 7. Now, you still have for your first spot 12 options because you haven't picked any songs yet. For spot number 1, you've got 12 options. And then 11, and 10, and 9, and 8, 7, 6. Multiply them together. Mr. Calculator for us. So we've got 12 times 11 times 10 times 9 times 8 times 7 times 6 equals, was it 3991680? So 3,991,860 ways for just 7 songs. Now, I'm going to caution you on the next problem that the number may be so big it does not fit in your calculator. All you'll need to do is you'll multiply the stuff you can using your calculator, and you might have to do 1 multiplied by hand. It says here your band has written 12 songs, same scenario. How many ways can you arrange all 12 songs on the CD? So if you fit all 12, how many ways can you put them in different orders? Pause the video, do that problem right now, including the multiplying by hand if you have to. When you're ready to continue, hit play, and then we'll go through it together. Okay, so you had 12 permute 12, because you're using all 12 songs. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you need to take 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, you multiply that all out. I think when I did this on my calculator at school, I was able to multiply these numbers together, and that fit in my calculator. But then when I tried to take it times by 3, it gave me some error message, like error overflow, too big. So then what I had to do is I had to take that answer and just times it by this by hand. Now, you could take the answer from this and times it by 3, and then times it by 2, or 3 times 2 times 1 is 6. Take the answer from this and just times by 6, and you get it in one shot. Answer, 479,001,600. Big number. Okay? So do the multiplies you can with a calculator. The ones you can't, you've got to finish it up by hand. And I believe when I did this problem at school, this next problem also does not fit on the calculator. But I would like you to try it. It says, suppose your band has written 15 songs. You'll record 9 of them for a CD. How many ways can you arrange those songs on the CD? Go ahead, pause the video, do this problem on your own. When you're ready to continue, hit play, and we'll go through it together. And I plugged the numbers into my calculator, multiplied, and that is the answer that I got. So I got, looks like, I'm trying to throw some commas in my brain. So 1,816,214,400. And we got that from doing 15 permute 9. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9 blanks. 15 times 14 times 13 times 12 and 11 and 10 and 9 and 8 and 7. Multiplying that all together, and you got that for an answer. It's a big number. That's what we got. Okay? So those are just finding permutations. Not bad. I personally find my way a little bit easier than using the formula. But the formula's out there, and you'll need to use it occasionally. Now, the last topic for the day is using permutations to find probabilities. So what you'll see in these next couple examples, it says, for example, a town parade you'll ride on a float with your basketball team. There are 12 floats in the parade, and their order is chosen at random. Okay? What is the probability of the basketball float coming in first and the chorus float coming in second? So we're trying to find probability that basketball comes in first and chorus comes in second. Well, this still sounds like a permutation because you're talking about two things in order. You want this thing first and that thing second. So if we do, well, there's 12 floats, and we're just looking at the first two, 12 permute 2. We get 12 times 11, which is 132. That's not our answer, because that is the total number of ways we can arrange all those floats in those first two spots. So that's the total of our probability. And then you got to think, well, how many ways is the basketball float going to come in first and the chorus float come in second if you're only looking at those first two places? And the answer is, well, one way. There's only one way that's going to happen, and that's if the basketball float comes in first and the chorus float comes in second. So if you're only looking at the first two, you need that order to happen. So there's only one way out of the first two floats that basketball comes in first, chorus comes in second. And that's how it looks. So that is our one way out of 132 total ways. With, you're talking about like the band and cheerleaders and baseball and, I mean, all the other possible floats that could be there. So the permutations finds the total, and then you've got to figure out how many ways can you be arranged for the probability. Letter B. What is the probability that the basketball float comes in first, chorus float comes in second, and the baseball float comes in third? So now we're picking 3 floats. So we've got 12. We're picking the first 3. So there's 12 options for the first spot, 11 options for the second, and 10 options for the third. Multiplying together gives us 1,320. This is 132. And to take something times by 10, you just add a 0 to it. So there's 1,320 total ways to arrange those first 3 floats. Now, out of those 1,320 ways, how many ways does the basketball float come in first, chorus second, and baseball third? Well, only one way. Because if you would switch these around, then it's not the correct order. There's only one way that this guy comes in first, this guy comes in second, this guy comes in third out of those first 3 spots. And that would have to be the order. Basketball, chorus, baseball. So the probability is 1 out of 1,320. Please try letter C. It's problem slightly different scenario. It says 10 students in your science class are giving reports on airbag safety. The order of the reports is chosen at random. Find the probability that your report is first and your best friend's report second. Pause the video, do the problem right now. When you're ready to continue, hit play, and we'll go through it together. Okay, so let's see. There's 10 total students, and you're picking the first 2. You're first, and your best friend is second. So the first 2 gives you, well, there's 10 options, 10 people to go in the first place, and only 9 would be able to go in the second, giving a total of 90 possibilities for just picking the first and second person to go. And then how many ways can it be picked so that you're first, or you are first, and your friend is second? Well, only one way. Only if you're first and your friend is second. If it's picked any other way, it's not going to work out. So 1 out of the 90. Hopefully that makes sense. I want to show one time the way the textbook does this, the way that the formula would do this. So here we're doing, the way that the textbook does it is they say the total number of permutations of this, the total number of ways you can arrange all these 10 students would be 10 factorial, right? Which would give you 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And the number of ways that out of all, if you picked all 10 positions, the number of ways that you would be first and your friend would be second would be like 8 factorial. Because you're basically ignoring the first 2 spots and you're just using the last 8. So if you did 8 factorial, 8 times 7 times 6 times 5 times 4, 3, and 2, and 1, and you go through and you do all that canceling stuff again, well, you're left with 1, because all this stuff canceled out. You'd still get a 1 up top. 1 over this 10 times 9, which is 90. So that's kind of how the formula method of this would work. Personally not a fan, but it does still work. I like using my way of just kind of using it, think about it logically. I think we've got one last problem from the textbook, summary, and then we're done. So here's the problem from the textbook. It says, suppose there were 14 floats in the parade. What is the probability that the soccer team is first and the chorus is second? Pause the video, do the problem on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, well, if there's 14 and you're picking the first 2, well, that gives us 2 blanks, and 14 times 13, I don't know, 14 times 13 equals 182. There's 182 ways you can pick the first 2, and if we're finding probability, well, only 1 out of those 182 will the soccer team be in first and the chorus come in second. And that's if soccer is first and chorus is second. Summary. So it says, how do you use the formula for permutations? Also, if you wanted to, you could also write down what is a permutation. Go ahead, pause the video, figure out how do you use this formula for permutations right now. Okay, you can see what I came up with. So I put down the formula for permutation. That's the formula we're referring to. I have to use the formula, you input the total options in for n. And the number of options you care about for r, then evaluate. So when we were doing like 12 permute 3, it means there's 12 possible things that could happen, but we were only picking the first 3. And homework comes from page 853, numbers 3 through 7, 16 through 24, and 36 through 37. Thank you for watching. This has been lesson 13.2. Bye-bye.